So hello and welcome again to another video. My name is Locho and today we're going to learn about types of bonds across a period. Okay, so we have three kinds of bond we have been able to learn. One was ionic bond, two was covalent bond, and three is metallic bond. So we need to know as we go across a period which kind of bond are quite prominent or are we going to encounter. So let's start. So the number of electrons in the outermost energy level plays an important role in determining chemical bonding. Element in period 3 actually exhibits variation in bond type, structure, and its property. So the first one is oxide of elements in period 3. And so atoms of sulfur and oxygen are held together by covalent bonds, but the molecules of sulfur 4 oxide are attracted to each other by weak van der Waals forces. And this explains why the boiling points and melting points are low. A question we may encounter is, why is melting point of sodium oxide lower than magnesium oxide? And the correct answer to that will be both sodium oxide and magnesium oxide have giant ionic structure. However, the melting point of magnesium oxide is higher because the electrostatic force of attraction between magnesium ion and oxide are stronger. This is due to the fact magnesium ion has a charge of +2 and is smaller in size than sodium ion. For silicon oxide has a giant covalent structure and each silicon atom is attracted to 4 oxygen atom and each atom is attached to 2 silicon atom. And so silicon uses all its valence electron to form a strong covalent bond with oxygen. The covalent bond in silicon are extraordinarily strong, and this explains why the melting point of silicon is 2231 degrees Celsius. So this bond therefore changes from ionic to covalent across a period, while the structure changes from giant ionic to giant covalent to molecular structure. Okay, now when we come to chlorides of element in period 3, we realize that sodium chloride and magnesium chloride dissolve in water to give a neutral solution, and these chlorides are ionic and they are able to dissociate fully into ions. However, aluminium chloride differs from the rest of the metals in period 3. Why is it so? And the reason to that is that it exists in a molecular form, in as much as it's a metal. So aluminium combines with chlorine to form aluminium chloride by covalent bonds, and 2 aluminium chloride molecule then combines through coordinate bond to form a dimer. And the equation below actually illustrates how that happens. So aluminium chloride plus aluminium chloride, where we can see covalent bond forming within the between one aluminium being surrounded by 3 chlorides, and therefore it forms a dimer where all the 2 comes together to form a dimer, and the connection between the 2 is connected by a dative bond. Okay, aluminium chloride dissolves in water to form acidic solution, and silicon 4 chloride also dissolves to form an acidic solution. and the equations are as shown below. So we realize that silicon 4 just dissolves in water, giving silicon 4 chloride, dissolves in water, giving an acidic solution, which HCl and silicon 4 oxide, while phosphorus chloride also dissolves in water, giving two acidic solutions. So both phosphorus 3 and phosphorus 5 chloride react vigorously with the water to form acidic solution and generation of heat. And the equation as shown below. So these reactions are usually referred to as hydrolysis. Okay, so thank you so much for watching, and you can like this video and give it a thumbs up, and also don't forget to subscribe for more content like this. Thank you so much. See you in my next video.